Okay, so the next section is just really an extension of section 1.3, and we're going to be finding perimeter and area in the coordinate plane. But we're going to be using that distance formula that we learned in the last section to help us find the perimeter. And then area, we're going to learn some new formulas for finding areas of different shapes. So if I look at this first problem, and I want to find the perimeter. Well, perimeter is just distance around a figure. So I made these segments nice because they're horizontal and vertical segments that we could really just count the length of each side. So from B to C is 8 units long. And I just counted from point B all the way down to point C. You could also take the difference in their x coordinates. 5 minus -3 is 8. And then on the opposite side, since the y coordinate of A is 5, and the y coordinate of D is also -3 like it was on BC, or I could count, I'm also getting a value of 8. And then from A to B, it's actually also 8, and from D to C is also 8 if you just counted. So the perimeter would be 8 plus 8 plus 8 plus 8, because we're just adding up all the side lengths, or you could just take 8 and multiply it how many sides there are. So our perimeter is 32 units. And we always want to label our units. In this case, we're in the coordinate plane, so it's just going to be labeled units. Now, is the quadrilateral square, why or why not? Our first special type of quadrilateral is a square, and that's when all 4 sides are congruent. And then all 4 angles are right angles, and in this case, these are indeed right angles. So yes, this is a square due to the fact that it has 4 congruent sides and it creates 4 right angles. So yes. And then area is just going to be, this is also a type of rectangle, but it's a more specific type of rectangle because all 4 sides are the same. But you're really just taking the length, which is 8, and then you're multiplying it by the width, which is 8. So the area is going to be 8 times 8. And then we write that in units squared because area is always in units squared. So for rectangles or squares, you're just taking length times width, or base times height if you want to treat it like that. So this guy is a little bit different because we've taken this rectangle and we've shifted it so it's kind of on a slant. So they're not nice horizontal and vertical sides. So what we actually have to do, so let's say I want to find the length of JH. It is congruent to ML because it is a rectangle, and I'm verifying that it's a rectangle, so opposite sides are congruent. So these lengths are congruent, and then these lengths are congruent. So let's say we want to find the length of the yellow sides. Well, we have to use the distance formula. So the distance formula that we learned in section 1.3 is x2 minus x1 squared plus y2 minus y1 squared. Point J is at -5, 0, and point K is at 1, 6. So let's treat this as x1, y1, and let's treat this as x2, y2. So now let's just plug everything into my distance formula. So I am going to, x2 is 1 minus x1, which is -5, so I'm subtracting a negative. Y2 is 6 minus y1, which is 0. So 1 minus -5, when you're subtracting a negative, it turns into addition. So that's going to turn into 6 squared. And then 6 minus 0 is also 6 squared. And then 6 squared, 6 times 6 is 36. So I'm going to have 36 plus 36, which equals the square root of 72. And then if you do type that into the calculator and approximate it, let's see what. It's going to be 8 point something. My calculator works, sorry guys. 8.48, so we could approximate it to 8.5. So that means this side is 8.5 units, and this side is 8.5 units, because they're the same. Now we could repeat the process for ML, but I know that those sides are congruent, so we don't have to. All right, I'm going to erase this part because I need more room to do the lengths of the blue sides, so you can always pause and go back if you need to see the rest of the work. So I'm going to erase this. I guess I could have kept the distance formula up there. And then I'm going to write the points for M and J. So M is at -1, -4, and J is at -5, 0. So let's do the distance formula. These are long problems just because this distance formula is. So let's do this as x1, y1, and this is x2, y2. So x2 is -5 minus x1, which is -1. y2 is 0 minus y1, which is -4. So again, be careful. This is -5 minus a -1, so it's really -5 plus 1, so it's -4. And then 0 minus -4 is really 0 plus 4, so it's 4. Now be careful here. When we square that quantity -4, it's -4 times -4, so it's going to be positive. And then 4 squared is also positive 16. So I'm getting the square root of 32, which is approximately, it's going to be 5.65, so we'll just say 5.7. So this side's 5.7, and this side is also 5.7. So again, pause it. I'm going to erase this just to give myself more room, because we got things going everywhere right here. So again, if this is 5.7, this is also 5.7. So to find the perimeter, again, pause it, go back and pause it so you can see the work. If we find the perimeter, I'm going to do 8.5 plus 8.5 plus 5.7 plus 5.7. Which is 28.4 units. Okay? Now to find the area, it's still length times width. So my length is 8.5. My width is 5.7. So let me type this in here. 8.5 times 5.7 should be about 48.45 units. And again, it's units squared because it's area. So these are the three main shapes we're going to be working with for perimeter and area. So if we call a square with 4 equal sides, if we find the perimeter, we're just going to do 4 times the length of each side because there's 4 of them. And then for rectangle, we're going to take twice the amount of the length, so 2 times the length plus 2 times the width. All right. And then for area of a square, it's really just 2 side lengths multiplied together, so it's just s squared. But it's really the same as length times width. So you could write it either or. I'll just put or, because it means the same thing. And then area of a rectangle is just length times width. For a perimeter of a triangle, we're just adding all the lengths up together, so A plus B plus C. And then area is actually base times height, but then you have to divide it by 2. So let's look at an example where we're finding area and perimeter of a right triangle. So the reason why this triangle is a little bit nicer is because 2 sides one's vertical and one is horizontal. So from A to C, I can count 1, 2, 3, 4, 5. So this is my attempt to find the perimeter. And from C to B, 1, 2, 3, 4, 5. Now this won't always happen where these 2 sides are congruent. This would be an isosceles right triangle then. That's when 2 sides are the same. So I already have 2 of the side lengths. Now I just have to find the distance from A to B. And again, that's going to be using the distance formula. So x2 minus x1 squared plus y2 minus y1 squared. So let's say, let's make this x1, y1, and x2, y2. And again, I'm doing this so I can find the length of this third side, AB, so I can add them all together to get the perimeter. So x2, 2 minus negative 3. Y2 is negative 2. Y1 is just positive 3. So 2 minus negative 3 is really 2 plus 3, so that gives me 5. And negative 2 minus 3 is negative 5 squared. So they actually end up both coming out to be 25. Because even if it's negative, it's still going to remain positive because we square it. So that's the square root of 50. So the square root of 50 is approximately 7.07 units. So this length is 7.07. All right. So to find the perimeter, I'm going to add 5 plus 5 plus 7.07, which equals 17.07 units. So that's my perimeter. My area is my base of my triangle, which this is my base, times my height. So it's going to be 5 times 5, and then I'm going to divide that by 2. So that's 25 over 2. So that's going to be about 12.5 units squared is my area. So these, we'll be finding the area and perimeter of triangles in the coordinate plane. If we were to give you a triangle like this, I'm not going to go through it, but this would be the base, and the height is the distance from the base to the opposite vertex. So you'd actually have to count this segment right here. This is going to be my height, so this is my base, and then this right here is my height. So if we do one like this, just make sure you're not using one of the diagonals as the height. The height is the distance from the base to the opposite vertex. So in this case, our height would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Our height would be 9. And our base would be 1, 2, 3, 4, 5, 6, 7, 8. So our base would be 8. So the area then would be our base times our height, and then divided by 2. So that would be 72 over 2, which is going to give me 36 units squared. So this was the area. And then for the perimeter, like I said, I wasn't going to finish it. You would just need to find the length of these two sides using the distance formula. So that's all section 1.4 is, guys. You're going to have a couple problems to practice finding area and perimeter in the coordinate plane, but we are just going to be sticking with these three main shapes, triangle, square, and rectangle for right now. If you have any questions, again, please reach out to us. We're happy to help you at any time. Have a good day. Bye.